Good morning, good afternoon, and good evening, everybody. Thank you for joining us wherever you may be joining us. If you're actually listening to this podcast and not streaming with us live, thanks for playing this back a little bit later. I'd like to welcome everybody to Data Engineers Lunch number 98. We are edging closer to that 100 mark, and I'm just happy everybody's able to join us for this one this afternoon. Let's go ahead and get started. We have a very interesting lunch coming up today. This is going to be a first in a series. We're going to have Alex on here as a guest. Alex has been on with us before, but moving forward, every first Monday of the month, we'll have Alex returning to expand on this series. We're really excited for the topic, and we'll go ahead and kick it off with the who, what, and why of data lake table formats this afternoon. So this event is hosted by Raul and myself. We are looking for speakers and sponsors for this event. If you're interested in either opportunity, please reach out to me at the email just listed below. We are a part of a larger community called Data Community DC, which believes in building an inclusive environment. So no matter your race, gender, or sexual orientation, everyone is welcome, and we expect respect to be given to all. Data Community DC is made up of a lot of different groups, generally all surrounding data. You can find out more about these groups at the links listed below. So what do we cover here? We cover everything from the ingress and egress of data and everything in between. If it is your first time joining us here, go ahead and introduce yourself in the chat, how you work with data, maybe how you heard about this lunch and what you're hoping to gain from data engineers lunches in the future. Group rules, if you have a question, ask it. We'd like to save all questions for Alex towards the tail end of the presentation. You can go ahead and drop them in the chat throughout the presentation, but they'll be asked to Alex at the tail end. So just go ahead and drop them in the chat. Like I mentioned earlier, please be polite and courteous to others. And we want this to be an inclusive event, an inclusive lunch every week. So we do want you to share what you know with us. Here at Anant, we design, build, and manage global real-time data and analytics platforms surrounding Cassandra, Spark, and Kafka. We'd like to thank our program sponsors, our organizational sponsors as well for their continued support. If you have any 15-second announcements coming up, any jobs, meetups, hackathons, conferences, or classes, please go ahead and drop a link in the chat with a short description. And then just a few housekeeping items regarding events. Obviously, we have our data engineers lunch every Monday, our sister lunch, our Cassandra lunch every Thursdays, same time at noon. And then we also have our no-code data and AI platforms every Wednesday at 1 p.m. Eastern. That is a little bit later. If you've missed any of these lunches in the past and you want to catch up, they're all available on demand on YouTube, so you can watch them on your own time. And you can listen to them as podcasts as well if you have YouTube Premium. And then finally, our latest runbook is out and available. If you haven't downloaded your version yet, this is still around. Please go ahead and download your free copy. I'll drop a link to that in the chat a little bit later on. And that's about it for the housekeeping items. I'll go ahead and hand it over to Alex for our presentation this afternoon. Over to you, Alex.
Hey, everybody. My name is Alex Merced, and welcome to this presentation, the who, what, and why of data lake table formats. So we're talking about what is a data lake table format? What problem is it solving? Why would you use it? What are the different table formats? Just sort of the idea is to walk away with understanding sort of what is this sort of newer space and why does it matter? And how do you get started? Okay, again, my name is Alex Merced. I am a developer advocate here at Dremio. I've worked as a web developer, data person in the past. I've spoken at a lot of events like Data Day Texas, OSACon, P99Conf, Data Council. Okay, I'm also the host of several, I'm also one of the co-authors of Apache Iceberg, the Definitive Guide. So it's an upcoming book by O'Reilly. You can get yourself a free early copy of the book by just scanning this QR code right there. Okay, and that's going to be all about basically how to set up Apache Iceberg, what is Apache Iceberg, all this stuff. A lot of the topics we'll talk today, and some of the subsequent appearances I'll have here over at the Data Engineers Lunch over the coming months. But I'm also the host of several podcasts. Okay, every week as part of Dremio, we do Gnarly Data Waves, where we bring on different guests to talk about different aspects of the Data Lakehouse platform. I also, with my counterpart at Dremio, Dipankar Mazumdar, we have a podcast called Select Star from Data Lake. and then my personal data podcast, Data Nation. All of these podcasts are available on Spotify, iTunes, and wherever you can find podcasts. So subscribe. I got a lot to say. I like talking about data. I like talking about tech. So good times. But with no further ado, let's just talk about sort of like, let's set the stage. This, because basically this is all part of sort of a larger trend that's going on. The data lake, the table format is part of the data lakehouse trend. And even bigger than that, there's just the big issue of big data scalability. So basically, we're getting to a world where basically the amount of data we're generating, the use cases for that data is expanding faster than ever. This creates sort of two problems. It creates a technical problem, meaning before you'd be able to use sort of like one platform, one tool, one database, and it could satisfy most, if not all, your use cases. Okay, I mean, prices and optimization, these are all considerations, but for the most part, you might be able to use a narrower set of tools. Problem is, the use cases are expanding, that really there is no longer the ability to say, hey, this is my platform. You need to have access to lots of tools to work with your data, because some tools are going to be optimized for different use cases at different times. Okay, so just the technological speed of use case of expansion of use cases that means we're going to need to use more and more tools. So basically having our data sort of in a box where you're using proprietary formats that only allow you to use a certain set of tools, it becomes a harder and harder proposition. The second issue is the cultural problem. Okay, the idea is that basically data is being so generated that when you're in that big data use case, it's hard to really make to have a centralized data team understand the context of all of that data to properly organize it, document it, and deliver it, and meet all those SLAs. And this is where you start meeting sort of the data mesh pattern, which is more, changing how we think about the division of labor, while the data lakehouse changes about how we think about the separation between storage and compute. Okay, so basically we move away from the old world of data lake and data warehouse, where basically you would have a data lake, you dump all your data in your data lake, which could be like object storage or a Hadoop cluster or whatnot. And you would run some ad hoc analytics on your data lake, mostly kind of read-only type queries. And then you would like ETL a portion of it to a data warehouse, and then you would kind of curate from there. You would curate data marts, BI extracts, and so forth and so forth and so forth. Instead, we're moving a world to a data lakehouse, where basically we turn that data repository into a much more robust tool. And what really enables that to happen is the table format. The table format acts as this metadata layer, so that way all those compute tools you would use on your data lake before can go beyond just read-only, but they can now start doing more like ACID transactions. They can do more write type jobs. A lot of the workflows that you would normally maybe wait to do on the data warehouse, you can do directly from the data lakehouse. Okay, this is becoming such a trend that now even data warehouses are shaping their compute to be able to operate on your data lake data. So really it's becoming saying, hey, put your data in this format. Using a table format, you can have your data stored in your data lake. And whether it's a data warehouse platform, a data lake query engine, or any kind of tool, you can access that data and be able to, use the tool that best fits the particular use case that you need. Okay. And then there's also a discussion of catalogs that allow us to discover those tables using that table format. Okay, so essentially the distinction here is we're injecting that table format that provides the metadata for engines to do more with the data in our data lake, which allows our data lake to behave more like a data warehouse, thus the term data lakehouse. Now, there are three sort of main formats that allow you to take your data lake and turn it into a data warehouse. And each of them have a different sort of architectural design that has a little bit to do with sort of like their history and why they exist. The first one is Apache Iceberg. So like Apache Iceberg was created out of Netflix. Like the challenge they were trying to overcome at the time was a challenge with the Hive table format. Okay, using Hive at Netflix, a lot of the queries were really slow. And the reason being is that Hive typically would track, the way you would track a table is by a directory. You'd say, hey, this folder and all the files in this folder is a table. If there's any subfolders, those are partitions. So you didn't track individual files, you would track directories. Even the Hive metastore would just track sort of this directory is the table and these subdirectories are the partition. So when it came to ACID transactions, the best you could do was do partition overwrites like that you could have ACID transactions on, and you could overwrite like one partition at a time. But aside from that, you didn't really have as much flexibility to do a lot of write jobs, especially more granular write jobs where you may only want to update one row or something like that. So you had consistency issues once you started trying to get into more expansive type jobs. It wasn't as performant as it could be. And so basically, Netflix wanted to address all these problems. So basically, this resulted in the creation of the Apache Iceberg table format. So basically, the big innovation here is that instead of looking at a table as like a directory and subdirectories, you're looking at it as a list of files. Okay. So that way, basically, this prevents a query engine from having to do any file operations, which would be very intensive processing-wise when you're listing a bunch of folders and having to list all the files in those folders and do all this stuff. Instead, what would happen is that a query engine, okay, so let's say like a Dremio, it would first communicate with whatever mechanism you're using as a catalog. Okay, we'll talk more about catalogs in future visits. But you would have a mechanism that acts as a catalog, a list of your tables that you have in this Apache Iceberg catalog. And it would say, hey, you know, I'm looking to run a query on table A. Okay, it would the catalog would then give back the location of the newest metadata file for that table. So think of it as like the newest table definition. Each metadata file contains like what's the schema of the table, what is the partitioning of the table, where are the different snapshots of the table, all that kind of information. So I would then figure out, hey, what is the newest metadata file? Okay, from that I can figure out which snapshot I want to query. So this is what enables things like time travel. So I can query previous states of the table. Okay, then that snapshot would have a list of, also known as a manifest list, would be a list of individual manifests that make that snapshot. And a manifest is a list of files. Okay, so essentially no file operations are needed. The catalog points me to the right file, the metadata file points me to the next file, and then the manifest list has a list of files for me to then determine which files I need to scan. And in those manifests, there's metadata for like each column in those data files that I can use to then be like, okay, well, I'm only querying people who are between the heights of 5 and 6 feet. Okay, does this file have people between 5 and 6 feet? Does this file have people between 5 and 6 feet? And I can actually narrow down how many data files between the metadata in the snapshot and manifest level to really only scan the narrowest number of files possible. Okay, so even if I narrowed it down to a partition, I can riddle that down even further based on the file level metadata. Okay, allowing you to have a much faster scan because you're scanning less files. And that's going to be the general idea with all three of these. The idea is like provide metadata so that way you can narrow down the scan to as few files as possible. Okay, but essentially it does it through this metadata tree. Okay, that's how Apache Iceberg works. Okay, then there's Apache Hoodie. So Apache Hoodie was born out of Uber. Okay, now Uber has a lot of streaming data use cases because you have cars that are constantly, driving people around. And that means real-time data is a real-time challenge. Okay, so Hoodie was really kind of created with kind of handling that sort of real-time data in mind. And so basically, the way it does it is that it tracks all the events that occur in the data. So in a table, it's tracking events, which are the individual commits that happen in a table, and it tracks them as a timeline. And then it tracks each event as a type of event. Is it a commit? So like, we added data, we subtracted data. Was it a compaction event? So we consolidated some files. Did we roll back to a previous point in time? So basically, not only do you have every event on a timeline kind of timestamp, but you have it categorized. And what this does, it allows Apache Hoodie is kind of unique in the sense that it's not just a standard way of creating the metadata. There's actually this sort of sister service that you would run called the Delta Streamer, and this then also in parallel optimizes the data underneath based on what it's seeing in the timeline. Okay, because again, the idea being, okay, hey, I got streaming data, I got real-time data. You want to optimize that data as it comes in. So it's really kind of built with that use case in mind. So it's not just not like Iceberg where it's a standard format, like a standard spec, and then everyone can read and write to that spec. It's more of a process plus some specification for handling real-time data and optimizing real-time data as it comes in. Okay, but again, so we'll all focus on a timeline. We'll focus on when do things happen and what happened in what order. Okay, and that came out of Uber. And again, the architecture of these things make a lot of sense when you kind of think about sort of, again, the context in which they were created. Netflix addressing those issues with Hive created Iceberg. Hoodie dealing with the challenges of streaming lots and lots of data constantly in the way Hoodie is architected. And then there was Delta Lake. Okay, so Delta Lake, you have Databricks, and Databricks has their platform. And, at first, you have Spark, and Spark's an engine that everyone's very familiar with. but you're wanting to operate, on the data lake, okay, and you want to make it performant to operate on the data lake. So they had to come up with a metadata format, so that way the Databricks platform had a way to sort of performantly interact with larger data sets on the data lake, okay? And essentially, the Delta Lake format was made particularly for, again, enabling that Databricks platform. It's an open source project, so you can use and write Delta Lake tables without Databricks, but the Databricks platform offers like a lot of things that make them sort of like allow you to optimize those Delta Lake tables, and it's really built sort of for that marriage. But the way Delta Lake works is that it works kind of like the way you would imagine like Git works. Okay, so if you use Git for like code, a commit isn't like a copy of every file. It's just basically saying, okay, these files changed, we added these lines and subtracted these lines, okay? And it's just a tracking of the changes from one point to the next. So essentially a delta log file, aka a commit, tracks any files that were added to the table and any files that were subtracted from the table from the previous log. Okay, so we'll say, hey, on the first commit, all the files were added. And let's say on the next commit, some files were added, some files were subtracted. And it just kind of operates like this. And basically by following from the first log to whatever log for the snapshot you're querying, it can reconstruct the table. Okay, now, of course, having to reconstruct your table through every log can get time consuming. Okay, having to just open up another file, make the incremental changes, open up the next file. So what they allow you to do is make checkpoints. So these checkpoints will summarize a batch of logs. So that way, instead of having to like iterate through each of these delta logs, this checkpoint can provide the summary of like, hey, between these three logs, this is the state of the table. So that way, you can start here and then kind of iterate there to kind of speed up when you're sort of reconstructing that table. Okay, so that's sort of like, now all three of them again have mechanisms for data skipping. So I mentioned like Iceberg, you had those metadata stats in the manifest and manifest list level, so the snapshot level. Hoodie has a separate metadata table that is separately used for like saying, hey, these files cover this range of data. Delta Lake also has separate indexes that are separate from the Delta log files that it uses for tracking that and doing that data skipping. Okay, on top of some like they have like newer features that are oftentimes usually like Databricks platform exclusives. Like I think right now, like the newest things like liquid partitioning, where it's just like dynamically reconstructing partitions. But I think that's something you have to use the Databricks platform to use. Okay, but those are sort of like the three different formats. Okay, now let's talk about different categories of features and which formats offer it. Okay, so when we talk about ACID transactions, okay, aka atomicity, consistency, so making sure the data is consistent and it's what it's supposed to be, making sure that, hey, when a transaction happens, either it happens in its entirety or doesn't happen at all. Okay, make sure we isolate these changes from other changes that are going on to avoid collisions, durability, to make sure that, hey, we don't lose the data. Okay, in the process of doing inserts, updates, deletes, and upserts, okay, all of these formats enable that. Like that's their core reason for existing, for enabling essentially these kind of workflows on the data lake. Like that's their purpose, to make sure that, hey, any engine can identify, hey, this is the table, here's the metadata for me to optimally plan a query, to do these queries straight from the data lake, instead of having to like make a copy of the data into like a data warehouse, which has its own proprietary sort of metadata that we don't see. Okay, schema evolution, the ability to update the schema. So basically, as tables change, because at the end of the day, data changes. Back in the day when you were using Hive, if you need to update the schema of the table, sometimes you just have to rewrite the whole table. It's like, oh, okay, that column should be called this, or that column should be this data type. Oh, well, got to rewrite petabytes of data. How fun is that? Okay, but with these formats, you can incrementally update the table without having to necessarily rewrite all the data, which allows you to add columns, remove columns, rename columns, changing data types of columns, reordering fields within different data structures. Okay, little nuances, differences between each format, but for the most part, they allow you to update the schema. Okay, efficient row level updates. Okay, so the idea is that now I want to just delete one row in a file. I want to update one row in a file. In the past, that could be a very heavy operation. Even when these formats first came out, you generally would start with like a copy on write approach. So essentially, if I updated one record in one Parquet file, it would have to rewrite the entire Parquet file. So a 1 gigabyte Parquet file may have to be rewritten for changing one record. Okay. Basically, each of these formats have now since adopted some sort of merge on read approach. Okay, that you can opt into for tables that need it. Okay, where you're doing frequent row level updates, meaning instead of it rewriting the entire Parquet file, it will have some sort of mechanism for tracking the delta or the change and say, okay, we're going to keep that old file. We're not going to rewrite it, but just know that that one record we need to ignore going forward. And then write a new Parquet file with that one record. Okay, so that way that write operation is a lot faster because you're only writing one new Parquet file with one record instead of rewriting a gig's worth of records for the change of one record. Okay, again, when you're doing frequent writes, updates, deletes, and merges, that can make a big difference. So Iceberg has merge on read, so any table can use merge on read, and allows you to set the setting at the operation level. So you can actually say, okay, updates are merge on read, but deletes are copy on write. You don't have to, it's not all or nothing. Okay, with a Hoodie, the table is either a merge on read table or a copy on write table. It's either or. Okay, so it's a type of table. There are two types of tables in the Hoodie universe. And Delta Lake, they were the most recent to adopt this, and I think it's still in preview, or it might have just got out of preview. And it's a feature called deletion vectors. So essentially, what they do is they have another data structure that tracks that delta, the deletion, basically the list of deletions for reconciling on future reads. Okay, but it's essentially the same idea. It's just a fancy way of calling merge on read without calling it merge on read. But so essentially all three formats have this feature now. Okay, now when it comes to Z-order, being able to sort your data in a Z-order style. So this just allows you to sort the data evenly among multiple ranges. So I basically imagine if I were to take all the data and say, okay, I'm going to sort them on fields X and Y. So this quadrant, all the data with 0 to 50 on X, 0 to 50 on Y is, and I would basically break up all the data into these four categories and then write all the data to Parquet files based on where they fall into these four groups, which again then allows, like, hey, if I have a query coming in for X of 75 and a Y of 25, well, then only the Parquet files that get written here are going to be part of that query, which eliminates 75% theoretically of the files. I'm assuming that they're perfectly balanced. 75% of the files are not going to be scanned. Okay, and that's again the benefit of Z-order. When you're frequently querying based on like multiple fields, you're evenly weighing them, and now all three formats have a way of sorting the data that way. So that way, when you run compaction jobs, you can sort the data and get that Z-order, that benefit of Z-order, if it's appropriate for your particular type of query patterns. Okay, so they all allow you to sort, they all allow you to run compaction, they can eval schemas. Okay, where you start seeing differences are things like lakehouse versioning. Okay, so what do I mean by versioning? So in the same way that Git allows us to version code, we may want to version our table, version our data. Okay, and this allows us for lots of different things. We could use branching of our data, so that way we can isolate ETL work, so that way our mainline data isn't being altered while we're making those alterations and doing data quality checks. And that way we only publish the data once all the changes have been made and quality has been tested. Okay, so allowing to maintain data quality through that isolation. Data tagging in order to be able to replicate the data at certain points in time. So you may want to say, hey, here's my data at end of month, and you may want to tag it. So that way, if someone wants to query the data as it was at the end of the month, they can easily just query that tag. Okay. Again, not the data at the end of the month, the state of the entire data as it was at that point in time. Okay. Or merge. Another use case is like zero copy clones. Okay, so basically by creating a branch, you create like not a copy of the data, because again, you haven't created you haven't physically copied anything, but any changes you make on the branch don't affect the mainline branch in which the data is being consumed. So that way you can experiment, you can make changes to the data, run some, do some experimentation of the data without affecting the mainline and without having to duplicate the entire data set. Okay, when it comes to this data versioning, Iceberg is the only one that lets you do it at 3 different levels. Okay, you have catalog versioning using Nessie, which will be a topic of a future session. Okay, using Nessie or Dremio Arctic. Dremio Arctic is basically a Nessie as a service. Okay, so you can deploy your own Nessie server because it's an open source project, or you can get get one provided to you from Dremio Arctic. And again, that allows you to version the catalog. And the benefit of versioning the catalog is that you can then, if you have a problem with ingesting, like let's say you have failed ingestion on 100 tables, you don't have to roll back each table individually. You can roll back the entire catalog. Okay, let's say you want to replicate the state of the entire catalog. You can tag that catalog. You can create experimental branches on the entire catalog of data instead of an individual table at a time. Again, depending on your use case, maybe you only need to experiment on one table. Then table versioning, which is built into Iceberg, can do the trick. Okay, and then there's also file versioning, which you can do with Iceberg, but you have to use the LakeFS catalog. Okay, and the thing with Iceberg is that an engine to read your Iceberg data has to support the catalog you're using. So the LakeFS catalog just came out, so I don't think many engines yet support the LakeFS catalog at the moment. Okay, and now when it comes to Hoodie and Delta, they don't have this catalog mechanism as part of the way they work, which has some pros and cons. Again, you don't have to worry about having a catalog and that aspect of it, but also means they're more reliant on the file and directory structure of how the files are laid out. Okay, so with Iceberg, I could have files in completely separate folders and then be part of the same table, which especially for migration purposes is going to be really nice because I don't have to rewrite my data to migrate. I can use my data as it is and just say, hey, take the Parquet files I already have, make them part of the table. Well, that can be a little bit trickier with like Hoodie or Delta because it depends on sort of like, hey, there's this folder that's still organized in certain directories that sort of maps to the structure of the table. But either of them can use LakeFS because since they completely rely on the file system, then you're just when you use LakeFS, you're just versioning the file system and that works fine. Okay, so you have some options for versioning. Iceberg has sort of like the most robust flexibility with how you can do that versioning depending on your use case. Okay. Then there's like the issue of like format interop, okay? Because at the end of the day, you might need multiple formats, okay? You might use Databricks, so you're going to have some exposure to the Delta Lake. You might use Hoodie for some streaming, and you might pull a lot of your data in Iceberg, and you may want to kind of like use all of these together, or one or two or three, depending. So right now, this is a sort of a big discussion that's going on in the industry. And it basically like, okay, how do you make these formats play together better? One way you do is you use a platform that allows you to use multiple formats, something like a Dremio, where you can read Delta Lake and read and write Iceberg. So if you have tables that you wrote with Databricks to Delta Lake, but you have some Iceberg tables that you maybe, let's say, that you wrote in Dremio or that you wrote with Snowflake, you can actually open up both of those tables in Dremio, join them together, work with them together, generate and curate those data sets right there. So that's one approach to sort of creating interoperability between the different formats. OneHouse is creating a project called One Table, which allows you to sort of broadcast the metadata you have in a Hoodie table outwards as Iceberg or Delta Lake, so that way you can use other tools on the table. Delta Lake, with the announcement of Delta Lake 3.0, announced the idea of uniformat. And again, One Table and Uniformat have both said that eventually they want to be sort of two-way mechanisms where it works both ways between formats. I don't think either one has completed that full version yet. But Uniformat currently allows you what it allows you to do currently is only with Iceberg and read only. So essentially what you can do is you would write to Delta Lake and it would asynchronously write Iceberg metadata. Okay, which caveat is, since it's doing it asynchronously, there could be consistency issues because the Delta Lake table has already been written, but the Iceberg metadata, there's a gap in time and when the Iceberg metadata may be written. And also if you're making frequent changes to your Delta Lake table, it may batch those changes for the updates to the Iceberg metadata. So every snapshot that's available in Delta Lake may not be available to the Iceberg counterpart. And I think right now, in order to take advantage of Uniformat, you have to be using the Databricks Unity catalog. So in that case, you can't just use it standalone. You have to be using sort of the Databricks platform with Delta Lake to get that benefit. Okay, but But those are sort of like different ways you can have these sort of formats kind of play together. Again, this is early stages. Chances are probably the most robust way to do it is just with like a platform that just supports multiple formats. So that way you're just using the formats as they are and allowing the engine to kind of handle, the joining and all that stuff. That is the main portion of this. But first off, I want to just say thank you guys for listening to this presentation. I do have one other thing I want to mention though, before I go back and plug the podcast. I forgot to put a slide about another feature called Partition Evolution. So Partition Evolution is actually a feature that's unique to Iceberg. It's a very important feature because what it does is that it makes it where if your partitioning changes, so let's say you're ingesting data and right now partitioning by month is working for you. Okay, so the data is partitioned by every month. You have all these partitions for each month. Eventually, the amount of data you're ingesting is growing. So it's starting to make more sense to partition by day. Okay, in any other format other than Iceberg, what would happen is you would have to go back and then rewrite your entire data set to a new table with a new partitioning scheme. Okay, so if you have petabytes of data, now you're gonna have to rewrite those petabytes of data to now partition it by day because you've decided now a newer partitioning scheme is more appropriate. With Iceberg, you can make an incremental change to your partitioning. You can say going forward, partition by day. So all the previous data would still be partitioned by month, but all the data going forward gets partitioned by day. Now, later on, if you decide that you want to run a compaction job on the entire table and rewrite the entire table, it would then rewrite it with the new partitioning scheme, but it's not required. And the compaction is pretty flexible too. You can say, hey, only only compact this partition, or only compact records that meet this particular filter or something like that. So you have some flexibility there. But again, that's something that's really unique to Iceberg. And the thing that kind of really enables that is that sort of that detachment from the file structure. It's not dependent on all those partitions being in particular subfolders. And that particular sort of unique aspect of the Iceberg architecture is what enables features like partition evolution and a lot of the other really cool partitioning aspects of Iceberg, because you also have hidden partitioning that allows partitioning to be a lot more ergonomic. But yeah, so those are the sort of the three formats. At the end of the day, what are a table format? It's a metadata layer that's going to allow engines to treat the data you have in your data lake like they're data in a database. Okay, that way your data lake just becomes one big giant database, so you can have several different query engines on. Okay, and those query engines can be dedicated data lake query engines, they can be data warehouses, they can be, and now you're starting to see databases that they can communicate with external tables in these formats. Okay, so we're moving more towards a world where, and for big data use cases, okay, because if your data is in one single Parquet file, then there really isn't a benefit to this. Usually the benefit to this is once your data starts expanding to multiple files, because the idea is that this metadata provides a way for your engine to not have to scan every file. It can determine which files it needs to scan. But again, if your entire data set fits in one Parquet file, then you're just fine with just one Parquet file. But again, as your data use cases expand and your data sets grow larger to multiple files, then using these table formats on your data lake makes a lot of sense. So you can have more performant querying of those data sets. And yeah, so again, if you guys enjoy this presentation, I'll be doing more presentations on this topic, talking about like Nessie, the Nessie catalog and catalog level versioning, talking about versioning in general and the comparison of the different versioning. We're going to be doing one presentation on optimization and just like the different ways you optimize data. So there's going to be a lot of really great presentations over the next couple of months. Again, first Monday, I will be here every month going for the next 6 months. These are podcasts that I do. So again, if you want to hear me talk more about all sorts of other random data topics, just subscribe to any and all of these podcasts on Spotify, iTunes, etc. And with no further ado, I'll open it up to questions. Okay, so let me see here. Can we say that Iceberg is leading the race in data versioning? I would say Iceberg offers you the most robust, because like I wouldn't say Iceberg is in the race for data versioning. The data, like you have different solutions for data versioning, and Iceberg definitely has the most flexibility when it comes to data versioning. So if that is a major, like if being able to experiment with data, branch data, merge data, do these kind of like experimental type features, and be able to do them in a tool agnostic way. Because I mean, I think Databricks does have its own sort of Git built into the Databricks platform. But again, if you want to be able to do this across tools in a sort of like vendor agnostic way, Iceberg is going to offer you the most like ways to do that, because the table, like generally, if you're using like the file system versioning with like a LakeFS, then it's again still not vendor agnostic. You have a vendor you have to kind of work with there. But if you're using the table versioning built in Iceberg, it doesn't matter what you're using. And if you're using Nessie, again, you don't have to use Dremio Arctic. I mean, we would love it if you did, because it's cool and we put a lot of work into that product and it's really cool. But you can deploy your own Nessie server. So you can have your own Nessie server that handles the versioning for you based on your authentication. So, you know, you want to have it authenticated through like people's AWS credentials. You can have your own Nessie server that you deploy and customize to your needs. Again, it's not married to any particular vendor. And that's something you can do with Iceberg that right now there really isn't a good like vendor agnostic way for versioning in Hoodie and Delta Lake. Like there's good versioning options, but they're generally always tied to some sort of vendor. Like LakeFS, I think it does have an open source alternative, but again, there's also like the vendor is the creator in a sense, which is fine. Again, these are if you use Databricks, it's fine to use the Databricks versioning. If you like LakeFS's product, it's good to use the product. But the idea is that when you think about the benefits of having vendor agnostic solutions, it's nice to have that flexibility, that lever to pull if you ever need to pull it. Okay. Which is the best format for a beginner to implement in a prod environment? I mean, it depends. I think all three of them are pretty easy to use up front. Like, I would say, I think, and all of them have come a long way as far as improving their documentation. But I would say first thing I would do is I would open up a Docker container with Spark and just try to like configure each one. I would say right now it's probably pretty close as far as like ease of use with Iceberg and Delta Lake. I'll give the edge to Iceberg just because you can easily do it with more tools beyond just like Spark, and do it pretty easily. Although again, Delta Lake has pretty good support among like the data frame libraries. Like if you're talking about like writing a Delta Lake in polars, and the Iceberg support there is expanding too. A Hoodie works with that Delta streamer process. So they're generally like to get the full production benefit from Hoodie, you do have to set up this process. You don't like, if you don't want to set it up yourself, that's the reason why like vendors like One House exists. So that way they can become your vendor that handle that aspect, that aspect side of things. But again, if you just want to like try it out, like to see that whole level, there is like sort of like, hey, I got to deploy the service on top of it to kind of see the full thing in action. While Iceberg is all libraries. There's no process that's built into the project. So there's nothing you have to like separately run or deploy. You just use whatever engine you're using and configure it to use Iceberg, and it just works. So like Dremio, you don't have to think about it. Dremio just automatically uses Iceberg. So in that case, when you're writing tables with Dremio, and we've just made the catalog integration even tighter. So basically, if you sign up for the Dremio cloud platform, like you're not gonna even realize that you're using Iceberg. You're writing tables, you're editing tables, you're doing all sorts of stuff, and you don't even realize you're using Iceberg the whole time. You just don't think about it. And that's the inevitable goal for all three of these formats. The inevitable goal isn't that, hey, I choose a format and I have to do all this configuration and set it up. The goal is that the tooling will just build that as a side. Because like, for example, you use your traditional database, you don't think about, okay, how is Snowflake organizing all the metadata for all these tables under the hood? It just kind of works. The inevitable reality that will happen with all these formats is as all the tools continue building in their integrations with them, that you'll just switch between tools, and it's just going to be using different data lakehouse table formats without you even thinking about it. And your data is just going to be in Iceberg or whatever format without even thinking about it. In that regard, I would say Iceberg is in the lead because it probably has like the widest reach of tools. But I mean, that's eventually all three formats want to kind of get to that place. Does it eliminate the need for backups? I mean, I don't think it's ever a bad idea to have backups, but backups just become sort of like become less sort of like the immediate mechanism, you're right? Because again, having to reload your data from a backup could be a time-intensive thing. Rolling back a commit is a lot less time-intensive. Okay, so it gives you a better mechanism for like light mistakes. So you're not having to rebuild your entire data infrastructure. But again, there are going to be situations where you might still want to back up, because where are those commits being held? Okay, so for example, depending on what the situation is, you may have a situation where your versioning data got corrupted. Okay, it generally shouldn't. But again, you still want to have those redundancies just in case you have a situation where you can't roll back a commit because multiple pieces of your infrastructure have fallen apart and you need to rebuild it. But I would say with versioning, many of the types of cases where you would have to like roll back to a backup and you have to wait like several hours for that backup to roll up would be just a quick, hey, just roll back the data to this commit and you're good and everyone moves forward. So you're spending a few seconds instead of a few hours having to get back to where you were, especially when you have catalog level commits, because you don't have to go back and roll back each table individually. You just roll back the catalog, and a catalog commit is a much more lightweight thing than a file system commit, because your file system may be tracking thousands of Parquet files and saying, okay, hey, well, each commit is, you're tracking this many Parquet files, while at the catalog level, you're not tracking the individual Parquet files, you're tracking the Iceberg metadata files. So it's really just table A points to this metadata file, table B points to this metadata file. So the actual sort of amount of data you need to track to capture that version is less. So the operations are just a little bit more lightweight. Okay, it was all new for me. Great session. Thanks, Alex. Could you suggest some free online projects that we can try on all these projects? There's great tutorials all over the web. I've written a lot of content specifically on Apache Iceberg. So there's an article I wrote, if you can quickly find it, it's on Dremio, dremio.com/blog. But literally, if you just Google Apache Iceberg 101, it should probably be like the first thing that pops up. And what I did in that article is I do have a video series where I go over a lot of the concepts in Apache Iceberg, but it also is a big directory of like tutorials and whatnot. And a good tutorial, so that we can get a flavor of Delta and Iceberg, is my I wrote a tutorial on how to migrate from Delta Lake to Iceberg. But in that tutorial, you do spin up a Docker container and set up Delta Lake with Spark. So you kind of learn how to work with both in doing that exercise. So you get it. So one, it shows you how to migrate, but it's also a great tutorial for just getting hands-on with. And I just put out a tutorial on Flink. So for those of you who've never worked with Flink before and always wanted to try Flink, my new Iceberg with Flink tutorial is, again, another one that really is step-by-step walking you through setting up all the Docker containers in a very systematic way. So that way, when you walk away, you'll not have just done it, but you'll have a better understanding of like sort of Flink and Nessie and Iceberg and how all these things kind of connect together, that you can walk away with feeling like, hey, I can confidently replicate this and work on this again. So I found those as two of my favorite tutorials. But if you go to that Apache Iceberg 101 article, you should be able to find a lot of this stuff sort of organized. I will add the Flink article to that directory as soon as I'm done here, because I don't think I've added that one to the link list. Any other questions?
It doesn't look like we have any other questions. If you guys have any other questions, just go ahead and drop them in the chat while we just do some housekeeping items before we close out here. Alex, I just want to say thanks again for another fantastic talk. It looks like there's a lot of interest in this series. Like both Alex and I mentioned, this is going to be ongoing. I think Alex will be with us again on September 4th. If you don't want to have to worry about marking that down in your calendars, you can subscribe to our YouTube channel. We have those spaced out. And also, whenever we go live, you'll get a notification as well. So please go ahead and subscribe to the channel. Also, if you haven't already, make sure you're in our meetup group, the Data Wranglers meetup group. We update it with all our data engineers lunches, all the topics and so forth. So you can kind of keep track of those. And like Alex mentioned, you can follow him on Twitter and on LinkedIn. I'm going to be posting that here in the chat here in a second. Let me drop that. And also, if you have any questions about the topic here today, you can leave them in the comments. If you're watching this a little bit later, you can leave them in the comments and or reach out to Alex at AM Data Lakehouse on both Twitter and LinkedIn. It's in the comments. Again, I want to thank you, Alex. Love the talk. Love having you on. I'm looking forward to September 4th. I'd like to thank everybody else for joining. Appreciate you starting the week with us. And yeah, I guess since there are no more questions, we'll see everyone at the same time, same place next week. Thanks, everyone. Have a great week. Awesome. Then let me go ahead and stop the recording locally.